Okay, so we're dealing with equivalent fractions, so I'd like to do a little review on how to find 3 different equivalent fractions from another fraction. So, what I do is I take my fraction 1/3 and I use the same structure we've used in the past. Whatever you do to the bottom, you do to the top. When you're finding common denominators, we're going to use that same structure. So I put times 2 on top and times 2 on the bottom. I put the 1/3 in a box because we will always go back to the original fraction to work with. So if we have 1/3 and we use our multiplication, 2 times 1 is 2, and 2 times 3 is 6. 2 6 is equal to 1/3. If we had a pizza divided up into 3 equal pieces and we ate one, and the same size pizza cut into a 6 cut, and someone ate 2 of the 6 pieces, they would eat the same amount of surface area, so therefore they are equal. And that would be in your explanation. They are equal because they cover the same amount of surface area. Here, then we would use the 3. 3 times 1 is 3. 3 times 3 is 9. So if we had a pizza cut up in thirds and a pizza cut up in ninths, one of the 3 pieces would be equal to eating 3 out of the 9 pieces if the 2 pizzas are the same size. This one piece would be covering the same amount of surface area as these 3 pieces would if the pizzas are the same size. Then we would deal with the 4. 4 times 1 is 4, and 4 times 3 is 12. So now you have a 12-cut pizza, and you're comparing it to a 3-cut pizza. This student would have to eat 1 out of the 3 pieces, and this student would have to eat 4 of the smaller pieces out of the 12 in order to equal 1/3. So 1/3, the 1/3 piece of pizza would be covering the same amount of surface area as 4 of those 12 pieces. That is why they are equal. You can do it also from the bottom down here and look at 2 fractions to determine if they're equivalent. Same structure. Whatever you do to the bottom, you would do to the top. So 5 times what equals 30? 6. Whatever you do to the bottom, you do to the top. 2 times 6 equals 12. So if I could use times 6 and times 6, and they come to those multiplication products, then yes, those 2 fractions are equivalent. If you ate 2 out of 5 pieces of pizza and 12 out of 30 pieces of pizza, and the 2 pizzas are the same size, 2 out of these pieces would be equivalent to 12 small pieces out of 30 would be equivalent to those 2/5 pizzas. They would cover the same amount of surface area. We could come over here and see if these are equivalent. So yes, these are equal. We're going to use the same structure we have used. 4 times what equals 16? 4. 3 times 4, whatever you do to the bottom, you do to the top. 3 times 4 equals, no, it equals 12. So 12/16 would cover the same amount of surface area as 3/4, but not 13/16. So no, those 2 fractions are not equal. They are not equal. These are equal. Knowing that, we can also show it with pictures. Let's see. I will keep this up there. We could have done area models. They're not going to be perfect. Area models are not my first choice to use because they are harder to draw and make equivalent pieces. These two pieces are supposed to be the same size, and they're hard to draw area models the same exact size. So if you have two equal area models, then you can compare. So here is 1/3, and here is 2/6. They are equal because they cover the same amount of surface area. If I slid this piece on top of that surface area, they would cover the same amount. That is how we know they are equivalent, based on if they cover the same amount of surface area. If I was also asked to draw a picture of my understanding, I could use the number line, which is my favorite method. Zero third. I always start with my denominator, so I know I have to write these into thirds and count by thirds. 0/3, 1/3, 2/3, 3/3. So now I have my number line, starting with 0/3, 1/3, 2/3, 3/3, and all of my parts or increments are equal distance apart. Otherwise, it's not accurate. So we want to know if 1/3 is equivalent to 2/6. So I could do a number line underneath it, or I could even do it on the same number line. I prefer to do it underneath it. And this is what I do. You must start in the same spot. 0, 6, so I'm counting by 6. 0, 6 is my first number on my number line. I must end my number line in the same spot. Just like our area models, they have to be the same size, so do our number line. So in this case, 1 whole is 3/3, well 6, 6 equals 1 whole. So therefore, 1 whole equals 1 whole. But in between here, we have to divide it up into 6. So I kind of go like this. Let's see. 1, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. I try to get my increments as equal as possible, drawing a number line. I think it's much easier to do it that way than doing area models. Now I want to know which fraction is equivalent with 1/3. From here to here and here to here, they cover the same amount of surface area. Okay, that is how I know they're equivalent. From here to here and from here to here. From 0/3 to 1/3 and 0/6 to 2/6, it's the same amount of surface area. So that's my little review on equivalent fractions. Miss Johnson signing off.